Welcome students. So today we are going to learn calculation of portfolio return and risk. So earlier we used to calculate risk and return for individual security, and now we are going to learn how to calculate it for portfolio. So this is an example we are going to discuss today. Now the stocks L and M have yielded the following return for the past 2 years. So here the data is given for the past 2 years. So here there is no probability will come. So by using past data, we have to calculate the portfolio risk and return. So we have two stock, that is L and M, and the data available for 1995 and 1996. Okay. So if we see here, so these just I'll put a line, draw a line over here. Okay. So L and M, the two stock returns we have 1995 and 1996. Now let's see the first question. What he's asking is, what is the expected return on portfolio made up of 60% of L stock and 40% of M stock? So here he's asking what will be the portfolio return. So if we are investing 60% in L and 40% in M. So let's solve it. So this will change ink color here. Okay, so we will write first solution. Okay, for question A. So now let's calculate expected return first for individual security. So expected return is equal to, so summation of R, that is the return, and divided by number of years, that is N. Okay, so for A, so calculating return for security L. Okay, we are calculating for stock L or security L. So if we see the data, so we have two values here. One is 12 and another one is 18. So we will take both the data here for calculation. So 12 plus 18 divided by 2. So is equal to 15. The return for stock L was 15. Now if we take return for stock M, okay, is equal to, so here values we have is 14 and 12. So 14 plus 12 divided by 2. So it's equal to, after calculation, so 26 divided by 2. So we will get the value, that is 13. So this is for expected return or average return of stock L and stock M. Now we have to calculate the portfolio return. So portfolio return. So okay, so we have calculated individual stock return. Now we have to calculate the portfolio return. So formula for portfolio return is, okay, summation N I is equal to 1. So Xi into Ri. So here X represent the weight that we have already calculated in earlier problems, and R represent the rate of return, that is nothing but average. Now if we calculate the portfolio return, okay, so in problem it is mentioned that, so if we are investing 60% in L and 40% in M, so weight for L will be 0.6 and weight for M will be 0.4. Okay, so let's do it. So here what we are going to do is, so we are going to calculate the portfolio return. So first we will take it for, so let's calculate it for L. So that is 0.6 into 15 plus 0.4 into 30. Okay, so if you see 0.6, which is given in the problem, that we are investing 60% in L and 40% in M. So after calculating, so if we multiply 0.6 with the 15, we get 9 plus, so 40% of 13, we get 5.2. So is equal to 14.2. So the portfolio return for L and M, including both the stocks, and investing 60% in L and 40% in M is 14.2. Now the second question is, find out the standard deviation for each stock. So now we have to calculate standard deviation of each stock. We have written with us. So let's calculate it. Now that is B, standard deviation. So to calculate standard deviation, we are going to use the formula. Okay. So summation Ri minus Rn bar square divided by N. Okay, we are going to use this formula to calculate the standard deviation. So let's calculate it for standard deviation for L is equal to, so putting in the formula, okay, the first written, that is 12, that is R, minus that R bar we calculated, that is 15, so square, plus the written for 1996 is 18 minus 15 bracket square. So divided by number of here is 2. So after calculation this, so we will get 12 minus 15. 12 minus 15 is minus 3. So minus 3 square. So we'll get 9. Okay. Plus 18 minus 15 is again 3. So 3 square is again 9 divided by 2. So square root. So is equal to, so after calculating is all 9 plus 9, 18 divided by 2. So it will be 9. So square root of 9 will be 3. So standard deviation for L is 3. Now if we do the same thing to M, calculating to M using the same formula. So we will put the values here. Okay. So 14 minus 13, that is R bar, bracket square, plus 12 minus 13 bracket square, so divided by 2. So after calculating this, so we will get 14 minus 3 is 1, so that become 1, square of 1 plus 12 minus 13 is again same thing, that is again 1 minus 1, so minus 1 square, it will be plus 1 divided by 2, so this. So after calculating 1 plus 1, 2 divided by 2, so we get the value, that is 1. So standard deviation for M security is 1. So here the question B ends. So the third question, that is C, is asking what is the covariance and coefficient of correlation between stock L and M. So let's calculate it. So solution for question C. Okay. So the question what is asking is, first we have to calculate the covariance between stock L and M, and then we have to calculate correlation coefficient. So let's calculate covariance between stock L and M. Okay, so we are going to use this formula. So covariance LM, that is the stock L and M, is equal to, so summation bracket Ri minus R bar into Rm minus R bar units R bar M, and because divided by N. So now we are going to put the values here. So we are going to calculate covariance. So we are going to use the formula. So let's put it in the values in the formula. So is equal to, so if we see the problem, so we know that return for the first 1995 is 12 minus R bar is 15, okay, into RM, that is for first year, for 14 minus 13, okay, plus here we're going to add, that is we have to use plus sign, then the second year, that is 1995, 18 minus 15 and 12 minus 13, so divided by 2, number of year is 2. So after calculating this, 12 minus 15 is minus 3, we get minus 3 here, minus 3 into 1 plus 3 into minus 1, 12 minus 13 divided by 2, so is equal to, so minus 3 plus minus 3 divided by 2, so we get the value here is minus 6 divided by 2, so is equal to minus 3. So the covariance between L and M is minus 3, so they are negatively correlated. Now let's calculate the coefficient of correlation between L and M. So correlation coefficient is between both the stocks. So we are going to use the formula, that is R is equal to covariance LM, that is covariance of LM divided by standard deviation of L into standard deviation of M. So if you put the value that we have calculated covariation LM here, that is minus 3 divided by standard deviation of L into standard deviation of M. So standard deviation of L that we had calculated, that is 3 into standard deviation of M is 1. So is equal to minus 3 divided by 3. So it will be minus 1. So coefficient of correlation or correlation coefficient between L and M is minus 1. So we have solved A, B, C. Now we have to calculate D. What is the portfolio risk of a portfolio made up of 60% of L and 40% of M? In question A, we calculated a return for L and now we have to calculate the risk between both the stocks when the 60% are invested in L and 40% are invested in M. So let's solve this. Okay, so this is most important one. Please pay attention over here. Okay, the formula plays an important role. You have to remember it. So the question solution for question D. We are going to calculate portfolio risk. So the formula to calculate portfolio risk is, so standard deviation P is equal to, pay attention, this is most important one. So we have to multiply X I square. Xi is nothing but the weight into standard deviation I bracket square plus X, that is X2 square, and standard deviation 2 square plus 2 into X1 into X2 into bracket R1 and 2, that is L and M, standard deviation 1, standard deviation 2. So the formula is most important one for calculating portfolio, and square root of this. Okay, so see here, X1 is the weight one, that if in problem it is given 60% we are investing in L, so that is X weight, standard deviation of security L, and X2 is just the what do you call, 40% we are investing in M, that is X2, and standard deviation of M. Here 2 into X1, that is the portion we are investing, X2 portion 2, R12 is the coefficient of, we call it as a coefficient of correlation. Okay, so and here standard deviation 1 and here standard deviation 2. Now let's put the values in this. So weight for security A is, so if you see 0.6 bracket square into standard deviation for 3 is, that is 3 square plus security M, we are investing 40%, 0.4 square, and the uh, standard deviation is 1 that we have already calculated, plus 2, okay, plus 2, 2 into 0.6 into 0.4, okay, into bracket, that is R12 that we have calculated, that is minus 1. So minus 1 into 3 into 1. Standard deviation of security L and standard deviation of security M, and this is the R12 which we have calculated. Now let's solve this, and we have to put here in the standard deviation. So after calculating the values, we will come to know. So here we come 0 square and multiplying with the 9. So we'll get 3.24 plus we get 0.16 plus in bracket minus 1.44. So why here minus 1.44 is that? The reason is the minus when the value of R12 that we had calculated. Now again, after doing this, so we have to root it. Okay, so after adding this all, so we get the value, that is 1.96, and rooting it, so we get 1.4. So standard deviation of the portfolio is 1.4. So remember, this formula plays important role. The xi, that is you can say x1, Okay, x1 bracket square, standard deviation 1 square. The x is the portion we are investing in the stock that will be given in the problem, and the standard deviation of the stock one. So x2 is the portion we are investing in security 2, and the standard deviation of security 2. So 2 into x1 again weight, x2 is again the weight of second security, r12 we have calculated, that is correlation coefficient, and standard deviation 1 and standard deviation 1, standard deviation 1 and standard deviation 2. So after putting all the values, we get that 1.4 is the portfolio risk, and we calculated portfolio return, that is 14.2 in the question number A. So here is the end of the problem. So solve it, pause it, take down the notes, so easy to understand it. So thank you very much.